Welcome to NeuroNex Michigan Hub, Multimodal Integrated Neurotechnology, also being called MINT. The mission of the MINT Hub is to provide a collection of tools synergistically enable structural functional mapping with greater scale and higher resolution than previously possible. We developed functional hardware tools for recording and modulation of neural activities, including high-density neural probes and microstrip carbon wires and fractal electrode to significantly enhance the signal-to-noise ratio in high-density recording systems. We also developed wetware tools for structural mapping, including clearing tissue and labeling neurons, combined with the brain-bow technology for construction of the connectivity maps. These tools will be disseminated to the community for functional and structural mapping at the scale. The MINT Hub provides an integrated solution including hardware, wetware, and software. Each tools will be developed in each PI's laboratory and will be disseminated through the hub after being validated in Bosaki Lab in New York University. In this video, we'll be introducing two technologies. One is the optogenetic probes developed in Michigan. The other one is AAV and clarity technology developed at CalTech.
We know very little about this neural network. However, if you have optogenetics, then you can genetically modify neurons in a way that some specific target cells are only responding to a wavelength, different colors. So we are developing the next generation probe, recording signals electrically, but also providing optical stimulation in the same chip.
We have 12 LEDs patterned at the tip of 4 penetrating silicon shanks, and I can control the timing of these 12 LEDs to stimulate different parts of the neural circuit. Prior to this technology, people are only able to attach a very big optical fiber onto micro wires. It's extremely inaccurate, it's big, so it's invasive, and there's very limited spatial resolution, so you're stimulating thousands or hundreds of thousands of neurons at the same time. So with this technology, we're hoping to stimulate even a single neuron at a time to study the connections between a very small neural circuit.
Electrode research has always been about eavesdropping on the neural activity that goes on in our brains. What we're doing is trying to develop tools to allow us to explore the brain with optics instead of just electronics. It's to create a foundation for a neural prostheses that would treat hearing loss, blindness, deafness, things like Parkinson's disease, Alzheimer's disease.
A key challenge has been the blood-brain barrier. This protective barrier prohibits both research tools and therapies from reaching the brain. What we are working on is to use the bloodstream to access the brain and spinal cord in a non-invasive way. We were able to deliver research tools across the blood-brain barrier and see the entire brain glow. A simple IV injection can allow us to impact Huntington, Friedreich's ataxia, ALS, neurodegeneration, Parkinson, Alzheimer. Setting the stage for what future of neuroscience research and therapy could look like.